All right. Good afternoon, everyone. This is the Alternative Intersections session. We have three speakers today. We're going to focus on new guidance, current best practices, and a few lessons learned. Our first speaker is Shannon Warhol. She's going to be talking on design guidance update on pedestrian and bicycle facilities at alternative intersections. Shannon's based out of Pittsburgh and works with local, state, and federal clients to develop solutions in multimodal safety design and operations at intersections, interchanges. And she has a special focus on alternative and innovative designs. Shannon has led projects investigating yellow flashing arrows, leading pedestrian intervals, offset T signalized schemes, grade separated intersections, and video-based monitoring of pedestrian and bicycle conflicts. Shannon's a member of TRB, the Performance-Based Geometric Design Committee, and is co-author of NCHRP's forthcoming guidance on PED and bicycle safety at alternative intersections and interchanges. She's also FHWA's working on FHWA's forthcoming second edition of the DDI informational guide. Our second speaker is Joe Rusevich. He's with Trans Systems. Joe's a senior engineer with Pittsburgh office. He manages the highway group as well as serves as project manager for highway transportation projects. Joe started his career at Penndot District 3 in design and project development unit. And he's currently on the board of ASHE Pittsburgh section as well as the steering committee for the conference here. He's also a graduate Bucknell with a degree in civil environmental engineering. And last but not least, Andrew Thompson. He's going to be talking about lessons learned for the US 22 Roundabout corridor. Andrew is a transportation engineer with Urban Engineers in their Philadelphia office. And through his role, he's led the design of trails, transit facilities, roundabouts, and safety improvement projects. Large focus of Andrew's career has been the development of roundabouts and innovative intersections that accommodate for all users. Andrew's also worked on transit projects for SEPTA, Amtrak, and FTA, and he's a member of ASCE and ITE and the Maysite Mid-Atlantic section. So with that, I'm going to turn it over to Shannon and take it away.
Great, thanks so much, Mike. Let me go ahead and share my screen here. Mike, can you just confirm you can see my PowerPoint?
Yep, I can hear it. I can see it.
Wonderful. All right. Well, thank you so much. Today, I'd like to give a little bit of a preview on NCHRP Report 948, which is the Guide for Pedestrian and Bicycle Safety at Alternative and Other Intersections and Interchanges. Quite the wordy title, but essentially looking at how do we design for pedestrians and bicycles at intersections. And I really think that, this session is geared toward alternative intersections and interchanges, but our report really focused on, in order to design and assess alternative and intersections and interchanges, you have to have a method that's applicable to all intersections and interchanges. So that's what we'll be focusing on today. Just a disclaimer before I start, the report is still in publication. Fingers crossed it should be due out next month. But so the materials here, we can record them, but just be aware that it's not quite yet published, but soon. So the purpose of the guidance is, again, to help practitioners improve and integrate pedestrian and bicycle safety considerations at intersections and interchanges. And we really focused on the process all the way from planning and design through operations and maintenance. So it really looked at the full lifespan of our intersections and interchanges. We wanted to consider moving beyond just the standard accommodations. So oftentimes we get into design and we're working on our operations. How long should our turn bays be? How many lanes do we need? And then we're moving into final design and we get all the way to the 90% plans. And then you pause and you say, wait, so where are we putting the sidewalks? Or what are we using? Bike lanes? Are we using shared use paths? You can get pretty far into the design without stopping to think about those things. And that's one of the aspects that we kind of wanted to change. So moving past standard accommodations. The guidance document, again, has a methodology that applies for all intersections and interchanges, but we did focus on 5 specific interchanges and intersections shown here on the screen. And there's a chapter for each of them specifically in the guidance. So considering the intersection context, we know that there are multimodal benefits of alternative intersections and interchanges. We use them because they reduce conflict points, and there's the potential for also reducing the pedestrian vehicle conflict points. By moving towards simplified two critical phase traffic signal control, we can reduce the confusion of pedestrians of when is their appointed time to cross the street. So there's benefits there. Alternative intersections tend to provide lots of ability for refuge islands. So breaking up the crossing distance to address pedestrians who may be moving slower or need additional time to cross for various reasons. We're also oftentimes looking at one directional vehicular traffic. So with that median divide, we're helping give pedestrians and bicyclists guidance about where the traffic is coming from that they should be looking for, and they only have to look in one direction as opposed to back and forth to look and check two directions. There are some reduced turn lanes and permissive turns. So depending on which strategy you're looking at, we can group all of our turning movements into one approach. So with the R cut, you're reducing those minor street left turns. So this does create some benefit with the left turn conflict with pedestrians and bicyclists. But of course, all of those left turns are making a right turn and then again going on to make a U-turn and potentially another right turn. So we've reduced one turn, introduced as many as 3 more turns. So that can be of concern. But there's great opportunities in alternative intersections for separated paths. In general, the land use that you would need for an alternative intersection is less than what you would need for a comparable standard intersection or interchange of the same capacity. And so why not use some of that extra land for pedestrians and bicyclists? Now, there are some drawbacks to alternative intersections and interchanges when it comes to pedestrians and bicyclists. And while we do provide for a lot of refuge islands, that can make for some confusing crossings for them. So here we have a displaced left turn intersection. You can see that to go from south to north or north to south, you have 4 different stages there of that crossing. It may not be obvious to a pedestrian standing at ground level exactly how to get across this intersection, and that's a real challenge that we need to be mindful of. Even though we've separated this, so we have each crossing, you're only moving across one direction of traffic, not always obvious which direction that traffic is coming from, right? So a pedestrian crossing at point D may or may not realize which way traffic is coming from and which way to look for potential vehicles. So these are all kind of some concerns that we have with the alternative intersections and interchanges. But in thinking about this from a performance-based design process, it's important to remember that alternative intersections are just intersections with some unique features, right? So I'm going to say that again. One of our engineers out in Portland, Brian Ray, is a big proponent of this. Alternative intersections are just regular intersections with some unique features. So we don't need to approach our design process in some brand new way. Approach your design process the way that you do for any other intersection, and then just key in on those unique features and really focus in. So from the mentality of approaching this like we would approach any other intersection or interchange, we have this performance-based design process, and it starts with identifying your intended outcomes. From those outcomes, you can then make your decisions and evaluate whether or not your design meets your intended outcomes. And so if your outcomes are not met, then you either need to adjust your outcomes or adjust your design. And we can repeat this cycle until we've moved to our construction set. The methodology that we developed in report 948 is intended really to be integrated with ICE, or the intersection control evaluation process. So we know that ICE, as it exists in, I think it's 8 states currently, and 6 or 7 states are working on ICE policies coming up. Pennsylvania has an ICE policy. A lot of those policies focus on operational impacts for vehicles and safety impacts for vehicles. And there wasn't a great quantitative measure of how to evaluate these at the planning level for pedestrians and bicyclists. And so one of the outcomes of this project was looking at a quantitative planning level methodology to evaluate our intersection based on those objectives that we identify in the first step. So the report details what we call the 20 question methodology. And so it walks through 20 different questions you should ask yourself about the pedestrian and bicyclist facilities at an intersection. There's a quantitative scoring way so that when you're in that alternatives analysis, you can objectively score one design versus another. Now, there was a whole separate presentation that focused just on this design methodology. It was, unfortunately, it was held in the last session, but there's a recording. So go ahead if you're interested in hearing more about this methodology, check out that presentation from Bastian Schroeder. But I want to focus on the specific intersections, those 4 of the 5 specific intersections we looked at in the design, and kind of unique aspects to be considering when designing these intersections. So for each of the 4 designs, you'll see that we have 3 or 4 different variations of how they can be placed. So here we have the median U-turns. In the top left, we've provided on-street bikeways with our sidewalks. We have mid-block crossings. On the right side, we presented an example of how a protected intersection concept could be applied to a median U-turn. And then on the bottom there, we have, oh, it looks like I have the wrong tag. It should be a shared use path concept for our bicycles and pedestrians. So everyone is off the roadway on a shared use path and then crossing with the pedestrian movements. 2 things you want to think about when considering median U-turns is that mid-block crossing. One of the great benefits of mid-block crossings, and a benefit even more so of the R-cut, is it's much easier to provide 2-way progression. So median U-turns still challenging because both the eastbound and the westbound are still coupled at that main intersection. But adding a mid-block crossing, while you do have to signalize the eastbound movement where they otherwise wouldn't be signalized, often this westbound movement is already signalized. And so if you can provide coordination from your main intersection through to your pedestrians, you may be able to get this mid-block crossing in really without major operational impacts to vehicles, but providing a huge benefit to pedestrians who maybe want to cross at a smaller spacing. So it opens up new opportunities to provide additional spacings for our pedestrians. The second thing to think about on median U-turns often come with the wider medians to allow for wide vehicle U-turns at those U-turn bays. Great opportunity to think about how to stage the pedestrians, whether you want them to cross in 1 stage or in 2. Important to think about though, if we're going to have them staying there for 2 stages, really nice to provide a welcoming area for them to wait, right? We don't want to hit the minimum 6-foot distance. I always think about if you're a parent traveling with a bike trailer, do you have your front wheel out in the road or do you have your kid out the back in the road, right? So 6 feet doesn't always accommodate everyone that's trying to move through our intersections. So if you're going to do that 2-stage crossing, use the right of way that you have, give them a nice area to wait so they don't feel like people are just whipping past them with inches to spare. R-cuts, then we had 4 examples of R-cuts. Again, on the top left, we have our on-street bikeway. You can see that we coupled that with a shared use path. So our green lines are our bicycle travel way. And so bicyclists here could either be on road or they could be on the shared use path. Nothing says that we can only give bicyclists 1 way to move through the intersection. Different levels of comfort for bicyclists. Maybe a bicyclist who wanted to make a left turn at the median U-turn instead of having to shift into that left turn bay can be very daunting on these 55-mile-an-hour roads. Maybe they choose to use an off-ramp onto the shared use path and cross as a pedestrian instead. Right side, we have that protected intersection concept. Bottom left, we have our shared use path. Looks like some of my labels didn't update here, but the shared use path concept And I'll jump into that one a little bit more here in a second. And then on the right, we have the rural cut-throughs. So not ideal here that we don't have a lot of pedestrian and bicycle facilities, but an easy way if we do have an arc cut that we want to retrofit, we can do that by just adding some easy cut-throughs for maybe it's a Saturday bicyclist group that rides through an arc cut often on the minor road, and they just need to cross that major highway, making some easy cut-throughs for them so that they don't have to go, make the right turn, the U-turn, and then the following right turn. Two things with arc cuts. You can see here on the left, we have an option that allows for more of a standard crossing style for pedestrians instead of that Z crossing through the center. One thing to think about here as you're doing it, and a really important reason to think about pedestrians and bicyclists, not at that 90% stage, but way back in our planning, this has signal impacts, right? So thinking about the capacity, the operations of the intersection, you now need to run this probably with one controller. Maybe you could do two if you want to have them two-stage crossing, but really does have operational impacts. So if you're going to go this route for pedestrians, you need to know that ahead of time. Similarly, protected intersection, you could even, depending on your volumes, get rid of all your left turns, right? So this is a modified arc cut where even Main Street left turns are not permitted, also an option. Displaced left turns, then, three options. On the left, we have our bike lane and the path. So again, bikes can choose to be on the road or on the shared use path. On the right side, we have our protected intersection concept. And then on the bottom, we have an idea that's called the median walk. So essentially, instead of making a pedestrian, if you think about a pedestrian in the northeast quadrant that wants to move west along the intersection, instead of making them detour well out of their way and going across the north-southbound roadway and then going back north to get up to the sidewalk, why not just walk them right down along that median walk? Now, requires more right of way. You want to make sure that that's, again, a welcoming environment that has lots of space. We don't want to just meet that 5-foot minimum, but a potential option to avoid extra distance traveled for pedestrians. Really important for DLTs, critical to think about them before you start your design. They have a huge impact on your operations. You have your outside pedestrian placement on the left and your inside pedestrian placement on the right. And what I want to talk about here is your left turn pedestrian conflict. So if you have your pedestrian crossings on the outside, you no longer can cross your pedestrians at the same time as that major street left turn, right? So a pedestrian crossing movement B would be in conflict with your eastbound to northbound left turn. Obviously, the great benefit of the displaced left turns is their ability to move all the east and westbound traffic together. If you have pedestrians on the outside, you can no longer move eastbound, westbound pedestrians with your eastbound, westbound left turns. So very, very important to understand from an operations standpoint how your pedestrians are going to be set up at this intersection, because it's going to impact the amount of time that left turn has to, all of your cues, essentially. If you need an additional critical phase, if you're going from a 2 critical to a 3 critical now, because those left turns need to be separated, great impacts on your cycle length and therefore your cues. On the right side, however, you can do an inside pedestrian crossing. You can see now a pedestrian who's crossing at crossing B could turn with those left turn vehicles. Now, requires a few more stages for your pedestrians, but the operations are a little bit better. So again, trade-offs, there's not that one is better than the other. They both have their pros and cons, but very important to think about from a design standpoint. And then the other thing that are featured in a number of these designs is this off-ramp feature. So here we have the crossover of a displaced left turn. Our displaced left turn is over to the left of this image, but you can see a ramp here for bicycle facility. So if a bicyclist chooses, they could remove themselves onto the sidewalk instead of going through the intersection on the main road. And then DDIs, again, we have our on-street bikeway on the left, our protected intersection on the right, and the shared use path on the bottom. A big thing for DDIs is the inside versus the outside crossing. I think a lot of people are familiar with that. One thing to really think about on that outside crossing, here we have our one crossover for our DDI. This is what we have highlighted here in the box is the entrance ramp to the freeway. The placement of those pedestrian crossings is critical, right? So we know that if we place the pedestrian crossing upstream of the center of the intersection, that we will vehicles will be traveling at a slower rate of speed because they're slowing down into the turn, and they're more likely to yield to those pedestrians. Also important to think about, can a vehicle even see our pedestrians, right? So if we have our truck here, we have a pedestrian at our blue arrow or blue dot. Do you think that truck can even see that pedestrian to yield to them? Very likely not, right? They're hidden away behind the curve. So thinking carefully about where those pedestrian crossings are placed. Also thinking carefully about where your pedestrian push buttons are placed. We still want to try and meet the APS 10-foot ProWag guidance, the separation of 10 feet between your push buttons. Important to think about how to place those. Here's our recommendation at your crossover of how to place those. So the DDI guide, this is a separate standalone report. It's coming out also early next year. So look out for that. There's additional DDI guidance for pedestrians and bicyclists in that report as well. I want to end my presentation where I started, with a disclaimer. None of these designs that we showed here are without flags, right? That methodology, the 20-question methodology, there probably isn't a design that is without flags, but it's critically important that you don't wait until your 90% plans to locate those pedestrians and bicycle facilities. You want to get them in there early during your alternatives analysis and let that assessment of the 20 questions guide your design from there through. So with that, I will stop. I'm not sure, Mike, if we're taking questions now or later, but I'm also happy to chat with people in the design session discussion lounge. So I will turn it back over to Mike.
Yeah, thanks, Shannon. Great presentation. A lot of information there to cover. So thank you. I don't have any questions on the chat feature or the Q&A. I think if we have any pop in, we can always go to them at the end. With that, I think, Joe, you're up. If you want to go ahead and start your presentation. Thanks, Shannon, and go ahead, Joe.
Sounds good. Can you see my screen?
Yes.
All right. So thank you all for attending our session today. This presentation is going to cover our project in Moon Township here in Western Pennsylvania and our eventual selection of the displaced left intersection as a traffic solution to improve the operations at an already challenging intersection. So the Moon Transportation Authority selected the Transsystems team to design the Stevenson Mill and Rouser Road connectors in Moon Township. The purpose of these projects are to establish a multimodal connection through Moon Township that will provide connectivity, system linkage, and support for planned economic development. Based on this planned development, a traffic impact study was undertaken to identify the needed improvements to the local traffic network. So who is the Moon Transportation Authority? They were established in 1986 by Moon Township to improve and construct transportation infrastructure that promotes economic development and enhances safety and welfare of the Moon residents. They're funded through the Local Economic Revitalization Tax Assistance Revenue Allocation Program, known as Alert or RAP. It's a mechanism that finances transportation infrastructure improvements in the designated transportation district. Properties within that district are exempted from local taxes on the value of new buildings or improvements to commercial properties for 10 years. And in turn, they contribute those funds to the MTA of the exempted taxes to advance priority transportation projects that are identified by the township. And right now, the current district, any building that has a permit issued on or before April of 2026 in this designated district is eligible to participate. So essentially, they're going to pay the taxes one way or the other, but this way helps advance local transportation projects within the network of where they're putting their commercial building. The MTA board consists of 2 Moon area school district board members, 2 Moon Township supervisors, and 1 Moon Township business member. So here's a zoomed out image of the project location located to the west of downtown Pittsburgh. Pittsburgh International Airport is in the bottom left of your screen. And Moon Area High School is located here, and Robert Morris University is located up here in the right. The area outlined in the box here is the intersection of Business Loop 376 and University Boulevard, and is the intersection we'll be focusing on today. So here's a little bit closer view of it, and you can see there's already a pretty busy intersection. We have 2 through lanes from the eastbound direction with 2 left turning lanes, 2 through movements in the opposite direction heading westbound with a dedicated right turn lane. Coming down off of University Boulevard, we have a dedicated right turn lane, a through left, and a left. And then from Horizon Drive here, it's mainly an old access, it's an access road to the some local businesses here and the airport. It has a left and a through right that turns into a dedicated right for them coming onto Business Loop 376. So to give you an idea of the scope of the project, here's a little bit of an overview map. So both the Stevenson Mill Connector and the Rouser Road Connector projects are going to create that system linkage. As it stands today, this portion of Stevenson Mill Connector, where you see the forested area, is not yet constructed. And this portion here of the Rouser Road Connector is not yet constructed either. So it's kind of a broken network that we're hoping to aim to connect. Other of interest is this is a Port Authority of Allegheny County park and ride facility. And this is also a U.S. Army Reserve base facility as well. So this area highlighted in red down here shows the project location. So to start off the project, we met with Penndot to go over the planned traffic count locations so that we could perform a comprehensive analysis of the area roadways. As we move the project forward, we continue to have regular meetings with the District 11 Traffic Unit to make sure they were on board with our proposed improvements. So here's a layout of our traffic count locations. We performed turning movement counts at 12 various intersections throughout the area and automatic traffic recorders or ATR counts at 5 locations. So University Boulevard is the spine here and Business Loop 376. So we counted all along University Boulevard up to this Moon Clinton Road, which are both Penndot routes, as the Stevenson Mill Connector would connect to both of those. And so we looked at the whole transportation network contributing to this area. So here's the resulting AM and PM peak hour counts at the intersection. Intersection 5 is our one that we're focusing on. The AM peak was 7:30 to 8:30, and the PM peak was 4:30 to 5:30. As we noted also, the Moon Area High School is nearby, so we did actually started the counts earlier to capture the departure time, just to make sure that that wasn't influencing the peak period in this intersection. As you can see by the counts down here at the lower part of it, we're dealing with roughly in the ballpark of 800 through movement vehicles and a significant amount of turning volume, 400 cars turning left on the approach to Pittsburgh, and the right dedicated right has 500 in the morning and 800 in the evening. So our project team completed a conceptual layout of the Stevenson Mill Connector with the input of the township and Moon Transportation Authority to help determine the number of trips that will be generated once the roadway is completed and the areas are available for development. We came up with a mix of modular warehouse space, office space, potentially a hotel and some restaurants and retail that would really fill out the area in this area. And this is what we used to get our trip generation to do our study. So here's the trip generation routing and assignment based on the gravity model. As you can see in the drawing, 85% of the traffic is coming from downtown Pittsburgh along the Business Loop 376 corridor, and another 10% is coming from Beaver County along that same corridor of Business Loop 376. So not a lot is contributing to the local network, and obviously without the local network being connected at this point, there's not a whole lot there. So here's the land use of that intersection again. This is a little bit older image than what I showed in the original one. This is about a year prior to our traffic counts in 2016. The northwest quadrant was a car dealership that was no longer in service. And you can also see a new hotel that was under construction. So it changed, the land uses changed pretty fast out here. Before we could complete our traffic impact study, it was noted there'd be some changes at this out of use car dealership. So a new retail space known as University Center was under development and would need added to the background traffic. So we used the planned land use that they were proposing to put in that development to add trips to the background traffic. And you can see now from 2019, that development's in place. The hotel has been constructed. So that was all now accounted as part of our base model. So again, we took that and assigned that background traffic based on the trips generated from the land use types. And then that gave us to our combined trip generation shown here for the overall model. So what project challenges were we now facing now that we had the model? The intersection of University and 376 is operating poorly at the current traffic volumes without adding any additional development. All University Boulevard turning movements and traffic movements are level F except the yield condition right turn. They're all failing today. And left turns being allowed for the eastbound business loop traffic heading towards Pittsburgh, it's adding a whole nother phase at the intersection for a single, though significant movement, while the left turn movements from the other direction have already been restricted. So we're allowing just the 2 left turns to go, adding a whole nother phase. So some potential solutions that we looked at, this all started before the ICE policy came into effect with Penndot. So we essentially did a mini ICE policy in that we looked at several solutions to see what provided the best solution at the intersection. So one thing we already, as I mentioned before, had 2 left turn lanes coming on eastbound 376 and a dedicated left and a through left, which very few through movements. So it's almost acting as 2 lefts coming off University Boulevard. To get that to work, triple lefts, not exactly ideal. There are some in this general Western Pennsylvania vicinity, but it's the concept of just continuing to build yourself out of problems, and more pavement in this area didn't seem to be the solution. So what we looked at was, can we provide an additional intersection at Hangar Road where there's already a signal on 376 to the west? Can we provide a roundabout at this intersection, or something more innovative like a displaced left intersection provide the answers we need? So this option we considered was to create a full 4-legged intersection at the existing intersection of Hangar Road and Business Loop 376 by making a spur off of the proposed Stevenson Mill connector. This would take a significant number of left turns out of the University 376 intersection and hopefully move it to here, helping to relieve the already poorly operating intersection. Those through movements are operating well. We could just add some traffic there. However, as we were moving the project along, it was determined that the spur road would lie within the runway protection zone of the adjacent runway of Pittsburgh International Airport. Upon coordination with the airport and the FAA, the roadway is not permitted within the RPZ, so this option had to be abandoned. We reviewed several alternatives for a roundabout. Some of the concerns were it would likely have to be a multi-lane roundabout, most likely with a 3-lane approach on that western leg heading eastbound, with right turn bypass lanes on at least 2 approaches. Motorists in this region are not used to modern roundabouts, so multi-lane as one of the first was not really an ideal solution. The bypass lanes would also be difficult to construct due to the adjacent properties. We just had that new development of University Center and just some other concerns in the nearby vicinity. One of the concepts we considered is shown on the screen. Even in this configuration, you'll see that that whole leg of the triple approach is already operating all at level service D, and the VC ratio at opening was already just under a 0.92. So we're pretty much at capacity with the triple lane already. So this didn't seem like a viable solution either. So the displaced left intersection was investigated as a third alternative to help with the increased traffic. Upon initial layout and traffic analysis, the results were promising. This was an early layout of the intersection. Upon coordination with Penndot District 11, they concurred with the proposed intersection type contingent on the modeling showing that it all work. So some of the highlights that you'll notice, what we did is we added this intersection to the west of the project location, and that would take those 2 left turn lanes and bring them and cross them over and have them stored along 376 to the north of the westbound traffic. So this would, it's one of the ideal solutions for this is it happens within the existing footprint mostly. We do have to push the pavement out a little bit to incorporate, but we only need about 1 additional lane of pavement as opposed to adding an additional lane on multiple legs. This solution would allow us just to expand a little bit and keep us from impacting that new development. So the current signal is 4 phases. The overall level of service at the signal was a D with around 49 seconds of delay, and it drops to a level of service E in the 2027 build scenario. So we'd violate the 10-second threshold that Penndot allows for the new development, so we had to come up with that solution. So that proposed displaced left turn that dropped it to 3 phases actually led to a 2027 build scenario of 40 seconds delay, slightly improving on the no build condition. However, we did notice some queuing of traffic on the westbound leg backing into a adjacent intersection. So it was noticed that we were showing that queuing backing into the intersection of Business Loop 376 and Airside Drive. This was due to the additional development of adding traffic to Stevenson and Rouser that's coming from Pittsburgh looking to turn right. The dedicated right turn lane that's there today only has about 300 foot of actual storage and a very long taper. And there's actually 675 feet of storage from Stop Bar to the previous intersection. So this intersection was originally agreed to be outside of the study limits, but with the potential impacts hitting at Airside Drive, we returned to count the intersection, added it into the model to ensure that we could come up with a solution that wouldn't have queuing issues back at Airside Drive. So ultimately, after several iterations and different looks at how we do the intersection, the solution that works is to make a dual right turn lane off of westbound 376 onto University Boulevard that will be signal controlled. There's 2 lanes to receive there, and we'll bring 2 lanes into it. We didn't feel it was safe to merge 2 lanes in. Penndot had concerns with it. So it was decided to have them brought in with signalization, but the dual lanes allow us to get the needed storage to make sure we get enough cars off of the through lane so they're not backing into that previous intersection. So then just to show what volumes we're looking at in the proposed condition, we were talking about 800 through movement and roughly, somewhere in that ballpark of 500 to 800 turning movements. You can see, I think this was 500 turning right movements in the morning. It's now 850. And then in the evening, it was 800 and it's now up to 1,059. So you can see that definite increase. Today's volumes were still fairly high in that area. So there's probably that there might be some backing and queuing issues today due to that low storage level, but this solution would help take care of that and handle it all. And as you can see, Horizon has very low traffic. So that wasn't a major factor in this, but this allows us to get those traffic movements. And in the morning peak, you're seeing almost 500 vehicles using that displaced left. So the final solution that we came up with, the University 376 intersection has a level of service D, and the actual displaced left previous intersection to the west has a level of service B, and Penndot asks for a weighted average. So those actually end up as a level of service D as well in the 2027 full build development with the mitigation in place. So what are the next steps on the project? The TIS has been approved by Penndot and the township. The project's currently in preliminary engineering. Final design is scheduled to begin sometime next year. And what we really hope for is that we look forward to coming back and showing off the final product with final design schematics and hopefully some construction images in the next couple of years. So with that, are there any questions?
That's great, Joe. I'm not seeing any questions in the Q&A. Again, we can answer questions during the other presentation or wait till the end if any other come up. That said, Andrew, why don't you give it a go? And if we have time at the end, I have a couple softballs for you. So with that, I'll turn it over to Andrew Thompson. Andrew?
All right. Let me get this set up. All right, can you see my screen? All right, I just want to say hello, everyone. As Mike said, my name is Andrew Thompson. I work with Urban Engineers in the Philadelphia office. Before we get started, I just want to give a special thanks to Mike Riebert now at District 6 and Jeff Booker at Central Office for giving us this assignment and allowing us to present on the study. Mike and I have been fortunate enough to work with Jeff as part of the Innovative Intersections and Interchanges Agreement with the Bureau of Project Delivery. But this includes this 222 and 662 roundabout study today. Briefly, this is an agenda of what we'll be speaking about today. First 3 sections focus on the project background, and the last 4 sections focus on the results and the analysis. So if it seems like I'm jumping around a bit, I am. Just for some project background, the study roundabout shown in blue fully opened in July 2018 as the first of many roundabouts programmed for the 222 corridor between Reading and Allentown. With the exception of the Kutztown bypass shown in green, the existing corridor is a rural 3-lane section that experiences as much as 20% heavy truck traffic and through volumes throughout the day. As you can see, 222 is fairly robust regional connector with about 26,000 ADT and 90% through traffic. Currently, signals along the corridor are experiencing significant delay with queues as much as a mile long. This roundabout is the first of many projects within the corridor that are planned. Our first roundabout and project along the corridor, which is planned to be widened to 4 lanes. So it's important to keep in mind that this roundabout exists in this interim condition and that things will be changed as part of the widening. This is just a picture of what it looks like out there today. So knowing that those future roundabouts are coming, the purpose of this study was to determine any lessons learned that can be derived from this intersection. Of particular importance was the modeling software. We do get into the SIDRA and HCM methodologies, and we did want to see which one is more accurate in this case. But to put this project development into perspective, the project was opened in 2018, but was analyzed in 2012. And since it was designed, there had been some updates to the HCM and roundabout design in general as a practice. It's been almost 10 years since the roundabout guide NCHP 672 was published, so it was important to see how the design was working. That said, both 222 and 662 are signed as north-south routes. So just for everybody's orientation and throughout this presentation, I'll be referring to 222 as east-west. This is a hybrid roundabout with 2 entry lanes on 222 and 1 on 662, also known as a 2x1. The roundabout itself, just for some size, has an inscribed circular diameter of 185 feet, so that's out to out. And one of the things that first came to light was that it was designed for side-by-side WB67 semi-trucks. So in 2012, Wisconsin DOT and Minnesota DOT published their joint roundabout truck study, which looked at how tractor trailers navigate their roundabouts. They came up with the 3 roundabout cases pictured, with differences being how trucks utilize those entrance lanes. So case 1 straddles both lanes, case 2 utilizes that gore area, and case 3, the truck is within their own lane throughout. There are a number of reasons to select the different cases, but some designers recommend case 1 regardless of truck percentages, because the tendency is that truck drivers tend to do what's needed to get around. So it was kind of a surprise when we found that the 222 roundabout was designed for side-by-side movements, which exceeds the most conservative of the truck cases. So that's one half of the equation. The second half of the equation is the design vehicle. If you're at my presentation last year, we covered this in much more detail, but as a quick one-on-one, this tractor, this is the trailer that governs the length, but the 2 dimensions we want to focus on are the wheelbase, which governs the swept path of the vehicle. In this case, the wheelbase is 67, hence the WB67. But oftentimes we see tractor trailers on the road and assume that it's a 67 foot because it's 53 foot trailer. But what we really care about is what's highlighted, which is that distance between the kingpin to the rear axle group, which is what really controls the wheelbase and the swept path. So for a WB67, that wheelbase is 46 feet. But when we look at the vehicle code, that limits the kingpin to rear axle group to 41 feet, which in reality means looking at a WB62. There are a couple of exceptions, but the overwhelming majority of tractor trailers in the Commonwealth are WB62s. And this is also consistent with the AASHTO Green Book, which suggests that we use 62 where it's applicable. For those reasons, we've been recommending that a modified WB62 be used because it accurately represents what's most commonly out there. So we have the 41 foot max kingpin to rear axle group, as well as the 53 foot trailer length. Briefly, these are all the data collection efforts undertaken for the analysis portion of the study, including gathering background information from the designer. But I just wanted to give a quick shout out to our partner, Imperial Traffic and Data Collection, which gathered the information. But to answer one of our major objectives of which analysis tool is more accurate, we took a deep dive into the analysis assumptions that were made during the design, first of which is growth. We wanted to see if the actual volumes in the field met the projected volumes. We were surprised to find that during the planning and design of the intersection and the corridor, the growth rate that was assumed was greater than the actual growth rate. So you had an assumed 1% growth rate, which doesn't sound like a lot, but when we compare what was collected versus what was projected, we have a 33% difference in what was projected rather than what was collected. So we wanted to figure out some reasons why. Why would this be happening? Why aren't we seeing the traffic that was occurring? One of the reasons may be that the actual growth rate in the region has been declining. So while not shown, ADT volumes on 222 and the cross streets have stayed around the same or decreased since it was collected in 2007. And this growth rate shows Penndot's compound growth rates for rural and urban roadways in Berks County. Both rates show significant decreases in growth. So it doesn't mean that traffic isn't growing, it just means it's more leveling off. Another reason why we aren't seeing the peak hour volumes is that the adjacent signals may be metering the vehicles that aren't getting to the roundabout, which doesn't fully explain the difference in ADT, but does explain why we aren't seeing the peak hour spikes. But part of that is there may be latent demand. Because this is known as a congested corridor, vehicles and drivers may be avoiding it for parallel corridors. The second thing we looked at when we were calibrating our model was the lane use during the peak hours. Regardless of peak hour, 70% of all vehicles are using the inside lane. And that's in stark contrast with passenger vehicles and single unit trucks, which utilize that inside lane as much, even greater. And semi-trucks tend to buck that trend with 60% using the outside lane. This image shows a typical scenario of what happens, where you have a platoon of vehicles that were released at the signals upstream and downstream, which are now stuck behind this tractor trailer. With little motivation from conflicting traffic, drivers tend to avoid the lane change. An additional reason may be geometric. Pictured are two examples of lane ads proposed for the 222 corridor. It's kind of difficult to see which one is the auxiliary turn lane and which one's for a roundabout. Compare that to this example in De Pere, Wisconsin. On Glory Road, we see this long flare that gives no preference for either entrance or either lane. And then even on the exit, we see that with a short zipper exit with no preferences given to who merges to who. Now that we had the lane utilization and turning movement counts, we want to do an apples to apples comparison of the HCM method, which is the US method, and the Sidra software. We used the new turning movement counts, and not surprisingly, we found that there was a significant improvement with the Sidra model. However, both VC ratios, which is that volume to capacity ratio, are less than the recommended 0.85, which is good news for the corridor because it means there's room to grow. In order to determine which model is more accurate, we compared the model to the field measured outputs, namely the maximum queue lengths. So we did look at the AM peak hour, which did have higher volumes, but when we compared the calibrated models to the max field queue lengths, the HCM queues are nearly twice as long as the field measured one. This intersection is only one data point, but from this result, Sidra appears to be the more accurate capacity model. Our analysis also covered identifying common driver behaviors. So our team watched 32 hours of video and identified 8 common driver behaviors, which I'll touch on briefly. First being that the most common is straddling both lanes while circulating. You may recognize this as the truck case 2, and is more common with trucks approaching from the outside lane. Trucks on the inside lane also use the truck apron when necessary. Second, we had trucks encroaching into adjacent lanes on entry. So they'll start on the inside lane and then they'll cross over into the outside lane as they're circulating, trying to take that fastest path. Third, it's additional 4.4% of trucks change lane from the outside entrance lane into the inside circulatory lane. So that's crossing from outside to inside. And this is, number 4 was more of a unique behavior with trucks with spread axles, but when truck drivers utilize the single circulatory lane, they tend to drive over the yield line of the cross street. Spread axles have wheelbases that are effectively shorter than WB62s, so it appears they're trying to avoid the truck apron, as you can see in the diagram. As you can see in this picture, WB62s, which have longer wheelbases, still have to utilize that truck apron. There are a few last behaviors that had lower percentages worth mentioning, which are yielding to no one, yielding within the circulatory roadway, failure to yield, and then oversized, overweight vehicles, which are fairly common. But in summary, 20% of trucks did not navigate the roundabout as designed, suggesting 1, that the roundabout is currently oversized. If you don't have vehicles next to you, there's less incentive to stay in your lane, especially if you're trying to maintain speed. The truck case is likely overly conservative. Since there's more room to make mistakes. And lastly, in regards to lane utilization, there appears to be insufficient motivation or cues for drivers to use both lanes. Next, we wanted to look at the preliminary roundabout reportable crashes. Although it hasn't been very long, in the 5 years before construction started, there were about 34 reportable crashes, compared to the 17 months between when the roundabout was opened and our study, when there was 32 crashes in 17 months. So if we extrapolate that linearly, that's approximately 113 reportable crashes in 5 years, which is a concern. When we looked at why, you can see that the crashes are concentrated at the multi-lane entrances, with side swipes being the most common, and almost all of the crashes involve trucks and a failure to yield. So we tried to look at some contributing factors, and part of the reason may be for the higher number of crashes relates to the underutilization. It's fairly common for multi-lane roundabouts. If there's lower VC ratio, you do tend to have higher crashes. Part of that has to do with the conservative truck case, which resulted in larger curb radii and maybe some faster paths, meaning that drivers may find it hard to yield in tight situations. And lastly, part of it may be the entrance geometry. You can look at this area here, that low angle between the circulating line and the yield line looks a lot more like a highway entrance where you're trying to merge than a roundabout where you need to yield. So one of the things we recommended is simplifying the pavement markings to make the entrance line more perpendicular with the outside curb. During our research, we found that similar improvements resulted in 37 to 80% reduction in property damage only crashes at other roundabouts. Something recommended in the 2012 joint roundabout truck study was additional signage on approach to educate drivers that they should avoid driving next to trucks within the circulatory roadway. And I know it doesn't sound like a lot, but the pavement marking can have a significant change to how drivers experience the roundabout. In the current condition, you have drivers almost looking completely over their left shoulder. Compare that in a proposed condition where it's directly out of their side window. We were also looked at to compare the fastest paths with the actual path speeds, specifically looking at what are called the R1, R2, and R3, which are the entering, circulating, and exiting speeds. So one thing to keep in mind, though, is that the fastest path analysis and methodology is not meant to look at expected speeds, but rather than theoretical attainable speeds. So as you might imagine, we expected speeds slower than the fastest path speeds. The table on the left compares the estimated speeds and maximum speeds measured, and the figure shows where those speeds were measured. As expected, measured speeds are below estimated, except with the exception of the southbound circulating and exiting speed. However, speeds do not exceed the acceleration method estimate, which is also mentioned in NCHRP 672. So I think it's important that we be take those V3 speeds with a grain of salt. We want to make sure that we don't overestimate their importance. Finally, we went out and performed field view and met with the Fleetwood Police Department and the Township Roadway Master. I have a lot of bullets, but I just wanted to touch on 3. The first things that the chief brought up that trucks were intentionally clipping cars against the truck apron. Often the police will chase down the truck and they'll have no idea that it happened in their blind spots. Drivers are aggressive. Number two is that drivers are aggressive to pass trucks at the roundabout, since this is the only opportunity for miles to pass tractor trailers. With 20% trucks, cars are eager to get by, but this will ultimately change with the final widening. Last, the Fleetwood Police Department police chief was noted that they're enforcing failure to yield and truck configuration. In his words, trucks need 3 panels from the end of the trailer to their wheels. So, in conclusion, based off of queue lengths, SIDRA tends to be a more accurate roundabout software based off of this intersection. One of the major lessons learned is that phasing these sorts of projects is important, especially if you're going to start the corridor improvements in the middle. Anecdotally, the police chief said that the roundabout was opened as a single lane during construction and there were no crashes. Compare that to when it was fully opened. And lastly, it's important to use the appropriate WB62, and less conservative truck cases may lead to fewer crashes moving forward. So with that, I will say thank you.
That's great, Andrew. Thanks for your summary of that recent report. And I guess with that, does anybody, we have 5 minutes for Q&A here for any of the panelists. Right now, Andrew, there's an open question about have roundabout designs accounted for the possibility of autonomous trucks?
I know that's something that's of conversation. I haven't heard any good answers for it yet, other than I know that they're working on it. Oh, I also wanted to, we had something in the chat that's about, from Steve Stewart, saying that the operation will likely change with the future 5-lane. And that's definitely something we talked about with the district and with central offices, noting that this is an interim condition. Things are going to change. So just want to highlight that. It's a good comment.
Another question came in. Was there any discussion on the potential for providing raised lane dividers in the circulatory roadways? We call them vein islands, something you see in turbo roundabout design. I could probably take a crack at that. We did look into that, and I know there's a few of the designers on the call or on the webinar here. We looked to potentially use like rumble strips or mountable curved vein island. I think that was recommended during the PE phase. However, at the end of the day, they didn't want the noise associated with them, and the maintenance group didn't really necessarily want those raised vein islands to be part of the design. That's my understanding. So a good comment and a good design element to incorporate on other roundabout designs.
Yeah. Steve also commented motorcycles were concerned with raised vein islands and rumble strips. And yeah, he also brought up
that's right. Yeah.
In another question he had that he was saying much of the criteria was still under development, which just want to agree with that. It's the purpose of the study wasn't to point fingers at anybody. Just a lot of things have changed.
Sure. One more clarification for you, Andrew. There was a question posed: have crashes been consistent through the 17 months, or were they staggered or more in the beginning?
We didn't see any sort of like clumping or grouping of the crashes. They were fairly consistent throughout the 17 months. I mean, crashes are random by nature, but they were kind of spread out. I think one of the good things that Steve also brought up is there were no fatalities during the crash period, which is something that's come up with multi-lane roundabouts before. Is maybe the number of crashes stay the same or go up, but the severity goes down significantly.
Right. Yeah, I think the fact that the district really wanted, and they were concerned with the high truck percentages and the side-by-side movements, they really felt that was going to affect capacity. So they really put a hard request in to have those WB67s travel side by side, as you noted, a case 4 scenario. And it really opened up a little bit more of the operational aspect and the safety side of things. We have time for one more question. I'm going to double back to Brian posed. Well, let's see. Shannon, do you mind expanding on the very first question we got? I know that you took a lot of time to expand. You're on mute. About the
Sure.
longer distance with the displaced.
Yeah, I can explain that. So the question was, doesn't the median walk have create a longer crossing? And so the answer is that the pedestrian spends more time in the intersection. They're not outside of the limits of the intersection because they're walking along that median. They actually have a little bit of an extended exposure area because where they're crossing the right turn, they now have to instead of crossing at the channelizing island, they're now crossing where the right turn is signalized at the crossover intersection downstream. So they do spend a little bit more time of exposure. The trade-off though is that because of the displacement of the left turns, oftentimes if you think about a pedestrian moving east to west across your intersection from the northeast quadrant to the northwest quadrant, a pedestrian tends to swoop north a little bit as the intersection widens. Then they have to come back south as they cross into that channelized island. They then travel west to their intended direction to cross the minor street. Then they have to go back north through the channelized island, and then finally head west and a little bit south as the lane tapers again. And so with the displacement of the left turns, you do get that distance, the north-south travel really adds up. And so the benefit of the median walk is that you're reducing that distance. So it has pros and cons to both. And as with most things, but yeah, I think they're a little bit, one of the big reasons to make that median walk feel more appropriate and have appropriate sidewalk spacing is because they are in the intersection, but they're not exposed in a travel lane.
Yeah, thanks, Shannon. We have a few more questions, but it is time to close up the session. As noted in the chat feature, please send any additional questions that you didn't get answered to the TESC@psu.edu email, and we'll get back to you. We're happy to discuss. It's kind of our passion on all three of us. Joe, Shannon, and Andrew, thank you so much for presenting today, and you may see some additional follow-up questions if the attendees so choose. Thanks, everyone, and enjoy the rest of the conference.
Thanks, Mike.
Thank you.
Thanks.